Hey everyone, welcome to this module on the of solid modules in Surpac. My name is Prakal Binzade and I will be walking you through the fundamental of solid modeling today. This module is crucial for everyone who want to become a Surpac expert for creating 3D geological models. Let's get started then now. Alright, first up, let's talk about what this module covers. In this tutorial, we will dive into what solid modeling is all about, where it's important, and how we'll go about creating, editing, and validating solids in Surpac. I will also be showing you step-by-step task to make sure you understand each concept in detail. By the end, you will able to confidently create, manipulate solids on your way. To begin with, let's make sure we have all requirements in place. We will need access to Geo via Surpac, a solid understanding of string file, and of course our triangulation method. Here the general workflow we will follow. First, we will prepare data, then move to the triangulation technique. After that, we will explore how to edit, validate the solids, and finally we will look to advance or explore how to edit validate solid. I might sound like a lot, but don't worry, we will take it one step by step. So what is solid model? In the simple terms, a solid model is a 3D representation of geological feature or mine design. Those models are really useful for calculating volume or understanding how the geology is structured in 3D space. You will often hear terms like vertex, segments, or control strings. Don't worry if those sounds new to you. We will explain, I will explain each as we go along. Let's talk about file structures. In Surpac, we will be working with several file types. Most of the time, we will come across string files and solid files. Solid file stands for .sol. Before we dive into a task, it's important to have a well organized, well work directory for storing those files. One task you will encounter for frequently is setting up a working directory for each project. This ensures your data stays organized and accessible. Next up is a data preparation. This step is a key to ensure everything runs smoothly later. One of the first tasks you will do is combine string files into the single files, which makes easier to manage. Once this done, you will check that string file description is crucial to make sure the string are facing the right way. Surpac provides a useful string files summary tools to have help with this. Now, when preparing the data, you will often issue like a folder backing or duplicate points. Don't panic. This is a quite common. We will use Surpac to identify and remove fold backs, which is essential incorrect, especially incorrect overlaps in a string files. After that, we will highlight and remove any duplicate points. It's a quick process, but it's make a big difference in the accuracy of and your model. Now come with the fun part, actually creating the solid module. We will start by using a triangulation technique called between segments. These methods allow us to create a solid between two set of strings file. Another technique involves using control strings which act as a guide for creating one more complex module. I will walk you through each step by make sure you are comfortable with the process. Once you got the basic down, we will move to the some advanced techniques like in Geovia Surpac. This is a bit more complex, but it's incredibly powerful. Allows you to model how one segment split into multiple segments, perfect for situations like fault zone or geological structures. The bunch out, we will go through tasks like performing from one segment to many segments and even merging segments together back. Speaking of faults, another key technique is fault triangulation. Faults are big tricky, but Surpac gives us a great tool to handle them. One in one task, we will use string wrapping to create a fault model, and in other, we will explore clipping faults to clean up the data. It's all about here. So I will show you exactly how to manage those tasks. Once we have our solids, we will need to edit them. Those involves tasks like renumbering objects, performing trisolation. Don't worry, I will explain those terms as we go. We will also learn how to validate solid to ensure they meet the required standards. I will show you how to fix any issue that comes. Think of this as a quality check. Next, we will look at intersecting solid with other projects such as a DTM surface. In this part, you will learn to perform union, intersection and outer section of solids. For example, we might want to clip a solid above a DTM limit. Our model of specific area. I will walk you through each task to make sure you are comfortable with those intersection techniques. One of the most useful feature of the solid modeling is the ability to report volumes. We will do tasks where we calculate the volume of solid, which is crucial for resource estimation in mining. Additionally, we will create a section slice of the module that shows cross sections of the solid. We will use both interactive methods and predefined range to create those sections. Once we have that sections, we can slice the solid using plain group methods. This is helpful for creating manageable chunks of data, especially when dealing with large model. After that, we will report the volume of each slice. This is a key step in resource estimation and analysis. Another important task is intersecting drill holes with our solid modules. These help us understand the relation between the geological data from the drill holes and the solid module itself. We will perform a task where we intersect drill holes with the solids to see what inside we go again. Finally, we will explore using points cloud for solid modeling. You will learn how to create a solid mesh for point cloud data, which is especially useful for more complex geological structures. We will also restrict mesh generation to specific area, whether by digitalizing a polygon or by selecting an existing closed segments. And don't worry, I will guide you through each step. Before we end up this, we will go over how to optimize triangulation, trisolation. This step refines the triangulated solid to make them more effective and accurate. It's all about getting the most precious model possible. To sum it all up, we covered a lot today. We started with the basic of modeling to move through data preparation, triangulation, and finally explored advanced technique like intersection, volume reporting, or working with the drill holes. I hope you now feel comfortable with your ability to create, edit, analyze solid modeling in Surpac. Thanks for sticking with me through this module, and I am super excited to see you apply those skills in your daily mining activity. That's it for today's session. If you have any question, feel free to ask. I'm here to help. Would love to hear your thoughts and feedback on this tutorial. Thanks again for your joining, and I will see you in the next module. Happy mining.